It is also recording. I should stop it now for recording stuff.
Sanskrit Computational. And later on, after maybe in the next lecture, I will go in detail how the tools are developed, the scientific angle behind it, or the algorithms that are used, the linguistic issues. All those things I will go in detail in the next couple of lectures, but today's will be a more kind of a general introduction to Sanskrit Computational Linguistics. How to get the next slide? It's not moving. How do we operate this? Okay, so maybe I will use this. Okay, so let me first talk about the technology. Technology actually is changing our life in the sense that it is extending the capabilities of our organs. I look at it from that angle. So if we look at the spear or hammer, they have extended the capabilities of hands. Bicycle, our legs, the capabilities increased, enhanced. Microphone, through microphone, we could reach a large audience. And telephone even allowed us to have the remote access. So the capabilities of ears are extended. Similarly, telescope or microscope, we have the capabilities of eyes are extended. Television, which is a combination of both, we could have remote access to the speech as well as the visuals. And finally, the computers, they have now extended the capabilities of brain. So both the numeric and logical, and not only just numeric and logical, but even linguistics, linguistic capabilities. As all of us know that human beings are special in the sense that they are the only living organisms who have these linguistic capabilities. And computers are now extending these capabilities. Now, see, this whole technology has led to, when the language is involved, a new technology, language technology emerged when computers came into life. So this language technology is language dependent. Now we use this technology for languages in the sense that gramophones we used. In gramophones, we could record the sounds, music, but that was language independent. Whatever song is from whichever language, gramophone worked well. We need not have to tune it for our languages. Similarly, tape recorder, telephone, television, all these we are using for communication purpose, for transmitting the voice, and all these technologies are language independent. Whereas when the computers came into being, the technology that emerged out of it is something language dependent. Now, what do I mean by language independent and language dependent? Language independent is something which we can use for any languages. We don't have to tune it specifically for any particular language. Whereas this language technology, for example, let us take the translation engine. Translation engine is to be tuned for a particular language. We cannot adapt it as it is. Or the OCRs that are being developed for, we need to develop it for different languages specifically. If I have OCR for English, for Roman script, it may not work for Devanagari. We need to have it, we need to train it once again right from scratch. So this is what I mean by language dependence. Whereas gramophone, tape recorder, telephone, television, everywhere, only the sound was converted to, say, electromagnetic waves or whatever, and then they were transmitted. And again, reconverted back. So there, the technology was totally language independent. So once we started using computers for language, understanding the communication, naturally, people were interested in knowing how the language works, where the information is encoded, how it is encoded, what is the information dynamics, how the, when you use different kind of words in a sentence, how the information flows, because different kind of word units will give rise to different kind of sentences, different kind of information, etc. So what is the information dynamics that is taking place? How information gets transferred from one language to another? These are some of the issues people were interested in. Or even how the how to extract language information from a language stream. So understanding and information extraction were the major issues. And unlike these gramophone, tape recorder, etc., where there was no effort towards the understanding, it was just transmitting the information, and there was no processing of the information involved. Whereas in language technology, we are now processing the linguistic expressions. We are no more interested only in the phonemes, but what those phones represent, what is the combination of phones when they lead to a word, what that word means, and when words are joined together to form a sentence, what that sentence means, etc. These are some of the these are the major issues which language technology was more interested in. And this led to the development of a new branch called computational linguistics. So this is an interdisciplinary field where people were interested in modeling natural language from computational perspective. Now, modeling of natural language, by that I mean modeling of the glyphs, the modeling of the glyph grammar, modeling of the pronunciation or the speech, modeling of the words, modeling of sentences, and so on. So on the one hand, the grammar was being used, which gave the linguistic, the science for the languages. And at the same time, they also discovered that, they also found that rule-based systems were not, the systems that were based on grammatical information were not sufficient. And then there was a trend to use the statistics, knowledge base, artificial intelligence, etc. And thus it led to the interdisciplinary studies. It was not just the language and computers, but languages, computational aspect was there. There was a mathematical or statistical aspect. Then there was a knowledge base that was necessary. So it became a kind of interdisciplinary study. So this computational linguistics may be considered as a branch of linguistics in which the techniques of computer science are being applied to the analysis and synthesis of language and speech. And of course, it's not just computer science, but later on, even the statistics and other disciplines started playing role. We also hear the term natural language processing. Now, is there any difference between natural language processing and computational linguistics? In fact, when in the beginning, when linguists started working on it, they were looking at it computationally, and thus the computational linguistics, this branch developed. And when and at the same time, the computer scientists were also looking at it, but they were looking at it from the processing point of view. The emphasis was on engineering aspect rather than the linguistic aspect of it. And thus the natural language processing, the name get coined in. But really, they are pretty much synonymous now. In the beginning, maybe in 1960s, 70s, there was a kind of difference between the kind of work computational linguists were doing and the kind of work NLP people were doing. But now, of course, hardly there is any difference. These words are being used synonymously. Now, when I use NLP, I also mean computational linguistics. But of course, when I use NLP, my more focus is on the engineering aspect of it or the product aspect of it. So these NLP people, they were more interested in real-time translation, question answering system, information extraction, retrieval, text summarization, spoken dialogues, reading the scripts, etc. And that led to various applications. So these were the areas of study, and they led to different applications such as translation systems, OCRs were developed, handwritten recognition systems were developed, speech detectors, spam detection nowadays we have. All these are the applications of various natural language processing systems, and even sentiment analysis and finding and comparing product information, as we see when we use Google or Facebook or whatever. There are advertisements which get tuned to whatever work we are doing. So all this is the miracle of natural language processing, because behind all these systems, this natural language processing system is running, which detects what kind of information we are, whatever we are typing in, that gets analyzed, and these machines continuously watch what we do, and then they project the advertisements and so on. So this comes under sentiment analysis and natural language processing. So let me give a brief history of computational linguistics. Way back in 1940s, the machine translation system, actually this machine translation was the very first, I would say, applications in computer science. During the World War II, there was this use of machine translation for detecting what the enemy's messages are, and then getting translated them, etc. And during those days, in Europe as well as in USA, there was this work on machine translation, but then in USA, the funding stopped in 1960, because they said that a lot of linguistic work needs to be done. And there was this ALPAC report, which stopped funding in the US, whereas the funding continued in Europe, and there were various groups which continued the work in Europe. And during 70s and 80s, there was some emphasis on using the statistics. Till that time, only the linguistic approaches were being used. Various linguistic formalisms were used for modeling the languages, etc. But then in the 70s, there was some emphasis on statistical methods. Actually, the hidden Markov model and Viterbi algorithms, they led to the, they were used in speech recognition, and they found it very much successful. And after that, the same statistical methods were used for languages also. So there were, on the one hand, grammar-based systems, plus they started using machine learning. Hidden Markov model also was one of them for statistical methods. For machine learning, they use both supervised and unsupervised learning. And IBM actually was very much successful in using these statistical methods. And there was just start of using these neural networks. And the IBM researcher, Frederick Jelinek, he says, every time I fire a linguist, the performance of the speech recognizer goes up. So, so what was happening was, see, a linguist or any person who is working on language modeling, he has to provide certain rules to make the system work. And these linguists were not able to frame the rules faster than the machine. The machine was able to build the rules faster. Now, these rules were not the rules which human beings can understand, but it was the statistics. So the statistics was providing a lot of good insights to improve the performance of the system. So actually what happens is when we use a language, it's not just the grammar, but along with grammar, we also use a lot of word knowledge. That word knowledge is encoded in these language strings. And when we want to process this language string, that information, which is outside this linguistic string, extra linguistic information, that is not available to machine. So when a linguist wants to frame any rule, he needs to go beyond the linguistic string. He needs to look at the word knowledge, ontology, or epistemic knowledge, etc. And we do not have any models of these so that a linguist can provide these rules very easily. On the other hand, the statistical methods, what they do is they look at the frequencies of the words or the collocations, etc., which gives us a lot of insight, not from the meaning point of view, but actual usage point of view, which can be then used to model better systems. And that's what happened during 1990s and till 2010. And 2010 was again, there was a revolution. These big data, how much big? It was in millions or trillions of words. I remember sometimes in 2007 or 8, Google released a CD where the frequencies of words, single word frequency, then pairs of words, their frequency, which are called bigrams, then trigrams, that is the 3 words together, the frequency of them. Like this, they provided a CD up to 5 grams. So unigram frequency, bigram, trigram, quadrigram, whatever, and the 5 gram frequency, 4 gram and 5 gram frequencies they provided. And that was used for improving the statistical based machine translation systems. And that also was used further in big data. I will come to that. So in big data now, it's not just these frequencies of unigram, etc., but now they are interested in just a collection of words. And that big data, using the deep neural network, they try to provide a kind of a vector model, vector representation for each word. Now, what is that vector representation for each word? You have the word So what they did was, they have huge corpus of million words or trillion word corpus. They can have the word frequencies. For each word, looking at the context, they had bag of words. Which words come with this word in which frequency? And that formed a kind of vector, that is, vector you can think of as property 1, property 2, property 3, n number of properties associated with the word. Now, one property can be which letters are being used, what are the phonemes that are used in the word. Then what is the suffix, what is the prefix, or whether it is a plural form or singular form, what is its gender, or what are the words, which are the verbs that come in context with that word, which are the nouns that come in context with that word, and so on. So they started preparing they started modeling this word using these various properties. And these properties, if I call these n properties as n vector with n dimension, they started talking of 150 dimension vector or 250 dimension vector or 1000 dimension vector, and so on. So for each word, these many dimensions of various dimensions were stored. And then they use this data for, so in a sense, these dimensions corresponding to this word became the meaning of the word. So meaning was represented this way. It was not the meaning that we perceive, we human beings perceive, but the meaning was represented as these dimensions. And that led to another revolution. So you have this deep neural network. I won't go in the details of what this deep neural network is, but using this data, they had the representation of word, which is, let us call it as a latent space. You have the actual linguistic space, and there is a meaning space or latent space, which is being termed in the deep neural network parlance. They call it a latent space. That means it is the meaning of these words. So they had the representation of each of these words in such a format, and that led to a better systems. Now, how it worked and how it works, I will explain a little later. And then a few days ago, you might have heard, or you might have read in the newspaper that Google has released Sanskrit translation tool. You give any Sanskrit sentence and machine translates into. Yeah. It works for English. I tried it, Sanskrit to English. It works very well. And I will give a demo in a short while. Okay, so this was this is some history of translation language technology. Let me come to Sanskrit Computational Linguistics. So actually, we started working for Sanskrit sometimes in late 1990s. There were all these individual efforts of Oliver Helwig, Professor Tera Hue, who is here, myself, Anand Mishra from Germany, and Peter Schaff from USA. So all of us were working individually on different aspects of language. And then we had exchanges during 2002 to 6. And then in 2007, as you had pointed out, we held the first Sanskrit Computational Linguistics Symposium here. And then it was followed by several other symposia. in various institutes. We also had international workshops, etc. And so far, more than 200 papers are presented, more than 100 are published on this particular topic itself. This is just from the symposia. There were other conferences also where papers from Sanskrit Computational Linguistics were published. And now it is a part of World Sanskrit Conference as well. In 2015 and 2018, we had these sessions in World Sanskrit Conference. And we also saw that in addition to this computational linguistics, digital humanities is also having, people are interested in digital humanities, and there are some efforts in this direction as well, as far as the Sanskrit is concerned. Now I have a question. We always say Sanskrit Computational Linguistics. We don't see the terms English Computational Linguistics, French Computational Linguistics, Hindi Computational Linguistics. Why Sanskrit Computational Linguistics? Well, there are a few reasons behind it. There are language-specific challenges for Sanskrit. First, of course, is accessing manuscripts, management of huge corpus. We have a huge corpus, which is at least 100 times the corpus of Greek and Latin put together in terms of manuscripts. Then dealing with the, we also have to deal with the influence of oral tradition on writing. And we also see that there are more text in verse form than in prose. But then you may also ask a question. Manuscripts are there for other languages also, not only Sanskrit. Of course, huge corpus is something where we need to deal with the huge corpus, fine. But if we look at the English corpus generated in the last few years because of the internet, I'm sure it is much more than the Sanskrit corpus. Well, dealing with influence of oral tradition on writing, I agree. This is something which is unique to Sanskrit, but it's not unique to Sanskrit in a sense that in Chinese also we have a kind of writing system where there are no word boundaries.
Some people try to connect a little late, so just let you go on.
Yeah. Okay. And then, so in a sense, all these three reasons which I have given are applicable to other languages also. This is something which is, I will say, unique to Sanskrit, more text in verse form than in prose. Now, because of these challenges, the focus is a bit different. Not only because of the challenges, but as far as Sanskrit is concerned, the focus is not just translation, because already important texts are already translated into various languages with elaborate commentaries. So what is important is not the translation, but the understanding of the text. What we are interested in is understanding the original Sanskrit text. And therefore, what we need is access to morphology or the syntax of it. We need a kind of assistance to understand the morphology, syntax, etc., so that we can understand the original text. So there is total change in the focus when we deal with Sanskrit texts computationally. And the second thing is, unlike other languages, Sanskrit is something which is unique in the sense that it has its own full-fledged grammar with good coverage, which is again close to mechanical treatment. Then the theories of verbal cognition also provide a sound theory for analysis. Thus, we have the grammar for analysis and the theories of verbal cognition for, grammar for the generation and theories of verbal cognition for analysis. So we have a full-fledged theory available with us. And therefore, naturally, the focus is more on using these theories or using this knowledge than just using the computational tools. And of course, there are some efforts in computability of Ashtadhyayi or modeling the Ashtadhyayi, etc. So these were some of the factors which made computational linguistics in Sanskrit stay it put it apart from the other computational linguistic work. In my opinion, the term Sanskrit Computational Linguistics, it deals with two things. Sanskrit for computational linguistics or computational linguistics for Sanskrit. So you are using computational linguistics to build tools for Sanskrit, and you are using the knowledge in Sanskrit, the theoretical knowledge in Sanskrit, to build computational linguistic, to enhance the computational linguistics. And the efforts in this direction, early efforts in this direction, Sanskrit, the knowledge in Sanskrit for computational linguistics, were at IIT Kanpur, Indian Institute of Technology, Kanpur. And the aim there was to use the Paninian grammar formalism for modern Indian languages. And the efforts there, they started sometimes in 1980s, and it resulted in a book, Natural Language Processing from Paninian Perspective, by Professor Sangal and Professor Vinit Chaitanya. This showed the successful use of Karaka framework for sentential analysis of modern Indian languages, where they worked on Telugu and Hindi. The concept of pravrutti nimitta was used to handle polysemy. Pravrutti nimitta is the reason behind using a particular term to denote a particular object. So the concept of this pravrutti nimitta was used to handle polysemy. When you have a polysemy, you have a word which is being used to refer to several senses which are all related, not totally distinct. So when you have a polysemous word, why is that you can use this word to denote this as well as this? And it's the concept of the etymology. The etymology is there with the pravrutti nimitta. Etymology decides what is the pravrutti nimitta. So the etymology tells you how you can handle the polysemy. So this concept was used effectively in developing these systems. Several language accessors for several language pairs were developed. And even annotated corpus was developed following the Paninian grammar for several Indian languages, including Urdu. This was from the use of Sanskrit Shastras for computational linguistics. Later on, I use these theories for parsing Sanskrit, on which I will say more in my next talk. Now, when we come from the other perspective, that is how the NLP has, how the natural language processing tools have enhanced the Sanskrit or the presence of Sanskrit in digital media, we see that we have the OCRs, transliteration tools being developed for Sanskrit. We have these word form generation analysis, etc., Sandhi joining and segmentation, sentential analysis. All these tools were developed. Even the translation system and question answering system is ongoing. So we see that the computational linguistics and Sanskrit, there is a kind of give and take happening. Sanskrit Shastras are giving some insights to do the processing. And whereas these natural language processing tools need not be developed following these shastras, but maybe taking insights from computational, whatever is happening in the area of computational linguistics, they have enhanced the appearance of Sanskrit in the digital medium. Now, these are two different aspects, and therefore I think the Sanskrit computational linguistics is it totally is a kind of different kind of activity that is happening in the world of computational linguistics. No other languages in the world have the give and take kind of there are no languages in the world where the theories for computational, not necessarily computational, but the linguistic communication is available for in any other language. But whereas we have here the Sanskrit theories, or I will say Sanskrit, the Indian civilization is the only civilization which has provided a good deal of theories for language communication, and these theories are being used, and maybe that is one of the things why the Sanskrit computational linguistics is somewhat different from the efforts that are going on in computational linguistics world. Yeah.
So in the meantime, some people have joined. So we have some more people now attending. And that is also because I announced it also in the Endology list, and through that also several people came. So, but that is quite covering everything last moment because of your visa problem. We were, I was a little hesitating. I didn't like to announce it and then to say, no, this is a postponed. So, so maybe also for people who are just now joining. Yeah, so we are very happy that Professor Ambakukani from Hyderabad University is here, and we will, especially in the next. So we have 2nd of June and 9 June and 16 June still coming. So then I will maybe reintroduce you in a better way like I did in the beginning. And so now we have also some reactions I saw in the chat, for instance, regarding the why specifically Sanskrit computational linguistics, and I think there was maybe we keep it to the end of your.
Yeah, sure.
Like you are now speaking for 40 minutes or something. So after 1 hour, we have some few times for little time for questions, and then we continue. So sorry to interrupt you, but that's just to know that there are a few more participants. And then we will continue. So please continue. I will try to write some, so people have subscribed, I have to put their link or their email. So it takes little time, but just go ahead.
Yeah, so, so far what I have explained, and maybe the question why Sanskrit computational linguistics, this is what just now I answered. And if there is a live interaction, maybe whoever has asked the question, maybe he may ask it if he has doubts.
We will do that after.
After this. Fine. Okay. So let me now switch over a bit to the translation. Of course, there are various tools which I would like to demonstrate, but these I will do little later. I would like to go for the various translation approaches, and why this translation, why a specific application I have chosen. The reason behind this is recently in the some 15 days ago, Google has announced Sanskrit translation system. So I thought it is appropriate to talk about the translation approaches and see what Google is doing and what are the other approaches and what are the differences between these. So under translation, we have several approaches, as I have mentioned earlier also. Way back in 1940s or 50s, the machine translation system started getting developed. And in those days, it was a grammar-based or rule-based approach. Then statistics came into being. Then there were example-based machine translations where machines were taught certain examples, and using these examples, machine would learn and then would try to translate a new sentence. There were human-aided machine translation where machine would analyze the source language and the human being will choose the correct analysis, and then machine will further translate it into another language. There was machine-aided translation also, where the translators who were actually working on translations of various literary texts or various official documents, etc. They use machines for translation purpose. So there was a kind of memory-based translations where the machine will remember that this person has translated this sentence into this, and then whenever such next sentence comes, then machine will use part of the sentence or phrases, etc., and provide a help so that a human being can translate it faster. And then we have this era of machine learning. I will show some demonstrations of both the Google translation, and we have an inbuilt system called developed at University of Hyderabad, which we call Samsadhani. So I will show you a demo of both these translations, and then we will see what are the pros and cons, what are the advantages and disadvantages of both these approaches. Samsadhani at University of Hyderabad, we are using the Paninian grammar and the Indian traditional systems, knowledge systems, to develop these machine translation system, whereas Google is using the machine learning approach. So let me show you the demonstration. Here are the sentences. Okay. Okay, so I have chosen a slok from Bhagavad Gita, and I will submit it to my system, and the same slok I will submit to Google also.
Okay, I did my homework. I sent everyone the link.
Okay, so here machine has produced the English translation, but seeing the army of Pandavas arrayed, Duryodhana then approached the teacher, and the king spoke these words. Now here, Duryodhana and the king are the same, but from this sentence, it looks like king and Duryodhana are different. Okay, it's Raja Duryodhana. It's the king Duryodhana. This is the only difference. Otherwise, the translation is very good, natural, if you see. And let me see what my machine has produced. Okay, I do not have the English translation, but it has produced. Can you read Devanagari? or no, you cannot. Then I will have to
switch to Roman script.
Yeah, I can switch to Roman script, but I'm not sure whether it will, because I recently shifted to a new system. I will check if it is working on this. Okay, it will take time. So this was one sentence. Let me take another one. How to get it down? Okay. No, but if I get it down here, then how to get rid of this? Okay. Let me take another one. Oops. What is happening?
In your Sanskrit sentence, you have already dissolved the sandhi, I think, so, which you submit from Google.
Huh?
You have dissolved the sandhi.
Actually, I need not. I need not. For Google, I need not. But for my system, I need to. Of course, for my system also, if I use the interface with Gerard's engine, then I need not. I can give complete string and machine can produce the translation. I will demonstrate these little later. So we have this Adyavanad Gramam Upetya Ramena Odanam Apache. Sorry, here Google does not take in IAST if I know correctly. It takes only in Devanagari. I tried, but it didn't work. If I type in Devanagari, it detects the language easily. Did you try with IAST? No. I didn't get with Roman script, and therefore I'm giving the input in Devanagari, and machine has translated it as, today I came to the village from the forest and cooked odan with Rama, which is wrong. Actually, today Ram came from the village and the rice was cooked by him. This is the, yeah. So, so machine has produced a perfect English sentence and you will think that this is the correct translation and you are misled, okay?
Maybe you should explain that the with Raman, that is Ramena, it can be with Rama, is together with it, or by.
Yeah, but this Apache, the verb Apache, this means it is in passive form, was cooked. So by Ram, the rice was cooked. Ramena is by Ram, Odanam is the rice and was cooked. When after returning from the forest to the village. So today he returned from the forest to the village and the rice was cooked by him. Okay, so so this is the problem with Google Translation, that the translation is very perfect. You feel that yes, this is the correct translation, but if you look at the original sentence, then there is a problem.
Odan is not an English word. We know that it means rice.
Oh, here, yeah, in English it has used Odana. Okay, fine. Because this Odana rice, this also it has, it failed to try.
So one lexical error and some
grammatical error. Yeah. Okay. Meanwhile, machine has produced.
This is not translatable in English.
Yeah.
Yeah, because it's very specific.
No. See, the problem is with sharing of the subject sharing. See, subject sharing is possible in active, not in passive. The subject of passive actually is the object, and here we have this having come from the village to the from the forest to the village. You cannot say rice was cooked. Rice has not arrived. it is Ram who has arrived. So this is again grammatical incommensurability between the two languages, English and Sanskrit. Yeah. Well, now let me go back to the previous one, the slok from Bhagavad Gita which I had given. Društva tu Pandavanikam vyudham Duryodhana tada acharya upasangamya raja vachanam abravit. So this was machine has now given the anvaya. It has given the prose format. Raja Duryodhanaha tada vyudham Pandavanikam društva tu acharyam upasangamya vachanam abravit. So this was a prose, poetry, and machine has now converted it to prose and also produced the par structure. You want some papers? Yeah. So here we have the analysis. Abravit, this is said, and who said and what did he say? So here the machine produces the correct analysis as Raja is the adjective of Duryodhana, whereas the Google Translator has separated the king and Duryodhana, and it appeared as if these two are two different objects, whereas here machine, our system has shown that this Raja is an adjective of Duryodhana, so the king Duryodhana. Let me also try with another sentence that Adya, this one. And if we give this to the system, then the machine will produce the par structure, though we do not have the English translation as of now. We are still working on the Hindi translation of it. But what machine produces is the parsed output of this sentence. So here is the parse structure where machine has produced the information that Rama is the karta of cooking and Rama is the one who arrived from the forest to the village. So complete past structure is given by the machine. And thus there is no ambiguity here in the analysis produced. Let me take one more example. And this time it is okay. This time it is from Bhartruhari, a philosopher, language philosopher, should I say, in of 5th century, you said, right? Yes. So before being Naga, the Buddhist philosopher. Yeah. Where is the sentence? Yeah. No, this is from the this one. Sorry, this is the eko raso karuna eva nimitta bhedat bhinna prutak prutakiva ashrayate vivartan bhavabhuti, not Bhartruhari. Sorry, it is from maybe by Bhattacharya's philosophy. Okay, yeah, but this is from Bhavabhuti. I'm sorry, and you see the translation, and maybe you can comment on this translation. One taste, compassionate. Now this compassionate is not the taste, right? It is the karuna rasa. Yeah, rasa. Rasa is translated as taste.
Yeah, it is a poetical emotion.
Yes.
Rasa in
Yeah.
poetry.
So this is the emotion. Compassionate is, and
it is the underlying feeling which you get after reading a piece of art.
Yeah.
It can be the heroic feeling.
Yeah.
When you read a war poem of Ilias,
yeah.
it can be a amorous feeling.
Yeah. So right. So first thing is the word rasa itself is translated in a wrong way.
Yeah, but how to translate it's untranslatable.
It is untranslatable. Yeah.
Rasa is its own philosophical or literary concept. The rasa
and,
of a poem, of a book, of.
And another thing is, yeah. And another thing is, if you look at the remaining part of it, one taste is different from the difference of causes, and as if separately it takes refuge of. So it's totally bad translation. The sentence looks very natural in English, but it's not the correct translation. Whereas if we look at this,
but this quotation about it is much longer.
I have not taken the second part. Yeah, second. Vivartan. That, yes. Thank you. So this part I have not yet added. It's only one part of it. And what machine has produced here, it has identified the adjectives properly. Rasa is the karta for ashrayate. Vivartan is the karma. So it has identified all these things correctly. So if you can now try to understand each of these words and try to see what is the relation of this word with this verb, you can understand it in a better way than just the translation. So with these three examples, what I wanted to show you is Google Translation, well, it gives you a very good natural English language translation, but there are certain issues with these. And what are these issues? Let me go back to my slides and where is the presentation? Yeah. So I will come back to this. So here are the differences between Google Translation and the translation systems that we are building. The aim of Google is to produce natural translation, whereas our aim is to provide access to the original text. The authenticity of the Google Translation is not guaranteed, as we have seen. Whereas in the case of Sansadhani, all possibilities are presented to the human being, who can then take the decision himself or herself. Then, as far as the transparency is concerned, Google is not transparent to the end user. In the sense, Google just produces the output, but what is going there behind the scene, that is not available to us, that is not known to us. Whereas in Sansadhani, I will explain this with more demonstration later on. Complete processing is transparent to the end user, because you can go through each and every stage and see what decisions machine has made. And if those are wrong, we can change the decisions and get the alternate reading also. Further, user has access only to the final output of the Google Translation, as again, same point I'm saying. Whereas in Sansadhani, user has access to the output at each level of linguistic analysis. As far as the comfort is concerned, Google, you don't need any efforts on the part of the user. You have maximum comfort. Machine produces the correct output. Machine produces the output. So it is something like you want to visit some place, but the road is not good. So the taxi driver says, okay, this road is not good. Instead of going to this hotel, why don't we go to that hotel, which is better because the road is good. So you end up going somewhere else. You wanted to go at one place and you end up going somewhere else because the road is not good. Whereas in Sansadhani, some efforts are needed. We say that, oh, road is not good, fine. We will try to make your journey as comfortable as possible, but you need to take some efforts. And so essentially human efforts are needed here in Sansadhani to make choices at several levels, etc. if machine produces wrong result. All the three examples which I have given, their machine has produced the correct output, but there will be some cases where machine produces wrong output. And then in such cases, we need to make the choices as a user in order to understand, or what machine has produced. I showed you just the graph. That graph is not enough. We need to understand each and every word, its meaning, what is the relation, and then we need to understand the complete sentence. So we need to put little more efforts. Reliability, as we have seen, Google Translation is not reliable, whereas in Sansadhani, we see to it that the output is reliable.
Judgment to say that it's not reliable. Maybe you should say sometimes reliable.
See, but how do we know? See, the translation is very good, but how do I know if I do not know Sanskrit? How do I know whether the translation is correct or wrong? Okay, so I need somebody who will tell me whether I should rely on it or not. So, and then what is Google good at? Good for getting quick translation. So suppose there is some manuscript. I want to know what is its content. So quickly it will give you some gist, and going through that gist, we may come to some conclusion that, okay, this belongs to this particular field, or that whether it interests us or not, that we can decide. Whereas in Sansadhani, it is good for getting authentic translation or authentic information. Okay, so now shall I break, or and then, yeah, if there are any questions.
So, see the chat for chat.
Yeah, here I can see the chat. Okay.
Okay. So
yeah, somebody has written Uttar Ramacharitam Bhavabhuti. Okay.
It's not quite true that there is no English computational linguistics. They call it corpus computational linguistics. That is the remark by
no, but corpus. Okay, actually, corpus computational linguistics is not just for English. It's for all languages. Yeah. Yeah. So, are there any questions they can ask?
There are 4 things.
Oh, okay. No, here I can't see.
I can read it.
No, I can't see the chat.
The next one is one random book, Charles F. Meyer. Oh, that is English corpus linguistics. Okay, so that is supplement to that question about English. Well, there is, so his view is that English computational linguistics is more or less the same as English corpus linguistics. And then there is Shaila Janakava has written that this quotation is in the Uttararama Charita.
Yeah, by Bhavabhuti. Yeah.
And I think that is all for the moment. These are the remarks in the chat. So,
okay. So,
thank you.
Okay. So essentially, English computational linguistics as such, there is no terminology, first thing. Then corpus linguistics is there. Yes, corpus linguistics is a terminology which is used to do any kind of linguistics using the corpus. So you have a huge corpus, you can do a lot of different studies, such as, so for example, here Google has identified the language. How it identifies the language? In order to identify the language, you need to study the corpus in the sense that what are the syllables which are more frequent in that particular language, which are the phonemes which are more frequent in that language, which are the words which are more frequent. And based on that, just by looking at some sample, say for example, there is some sample in Devanagari. Devanagari script is used by Hindi, Marathi, Nepalese, and Sanskrit, all the 4 languages. Now, if the text is in Devanagari, how do I decide whether it is a Nepali text or a Marathi text or a Hindi or a Sanskrit text? In order to do that, corpus linguistics is used. So what they do is, what are the characteristics of different languages? So those characteristics are found in terms of syllable frequencies, in terms of the phonemes, in terms of words, and so on. And based on that, they can decide very quickly that, say, for example, Visarga appears several times. Naturally, it is Sanskrit, because in no other languages, Marathi, Hindi, or Nepali, Visarga appears. So just by looking at...
Internally, dukkha.
Very, very rarely. Yeah, very rarely. But in Sanskrit, it is very frequent. So based on that frequency, comparative frequency, you decide which language it is. So in corpus linguistics, basically, these studies are done. So corpus linguistics is not specific to English. This is the answer to the question which is asked. Okay, so now let me come back to this. Before giving more demonstration, let me tell you how this, the theories of translation evolved over a period of time. So this is the Walkworth triangle, or it is also called a pyramid. So this triangle tells us that when you want to translate from one language to another, there are 3 different approaches. One is the direct translation. So essentially, you are looking at only 2 languages and try to model a system such that you can go from one language to another. In transfer model, you are doing some kind of analysis, maybe word analysis you do, and separate the stem from the suffix. And then you translate it into another language. This is a transfer approach. So when you are developing a system with transfer approach, essentially you are now not considering only a pair of languages, but this transfer approach can go along with several languages which have similar kind of syntax, which share a similar syntax. So for example, all European languages, or many of the European languages, can be fit with this transfer model, the translation systems among them, or many of the Indian languages can be fit in transfer approach system. So what we do is, if I have a Marathi sentence and I want to translate it into, say, Telugu, each word in Marathi, I will split the stem and suffix, and then just stem and suffixes I will translate back into the Telugu language, and then I use the word generator to join them together. And this works very well if the languages have close syntax. But if the syntax is different, then we need to do much more analysis, and there comes this interlingua approach. So in interlingua approach, what we do is, given a system, given a sentence in one language, we try to extract the information and represent the meaning, which is the Shabda Bodha, in an intermediate form. The verbal cognition that arises out of that sentence, we try to represent in some intermediary form, and from there we translate it into, generate into another system. This is the interlingua approach. And in machine translation, when people were following the grammar-based approaches, all these 3 approaches were followed by different people. And now in the machine learning also, they are doing the same thing. For machine learning also, in the beginning, when the machine learning experiment started, they tried to have a parallel corpus, say of English and French. And then machine learned from this parallel corpus. How it learned? There is, in Sanskrit, we have this avapa udvapa. That is, what can be, how to translate it? You eliminate something and then infer. So suppose you have two sentences, gam anaya and gam naya, or in English, let me say it, bring the cow and take back the cow. So when you say bring a cow, when you ask somebody to bring a cow, a person brings a cow and there is a third person who is observing this. So this person who is observing, he sees that this particular sentence is being uttered and this is the action being performed. And then when you when you are saying take back the cow, the person takes back the cow, the child is observing this, and then based on these two, the child infers that the object that is brought or taken back is called cow, and the actions also he now names. So this is, so how this is done, because the word cow was same in the both the sentences, and the same object is being transferred, moved, and therefore the child infers that the word which is common in both is referring to the thing which is common in both the actions. So this is the avapa udvapa process that is being described in traditional Indian systems. This is the kind of thing that is used for the parallel processing. So for developing a machine translation system using machine learning approach, using the parallel corpus. So you have an English sentence, you have a French sentence, and not just one sentence, but thousands of sentences together. So from this, now machine tries to learn what is the translation of each word, what is the translation of phrases, and so on. So it has this dictionary of all these. And now when a new sentence is given, then it tries to do a kind of greedy search, maximum match, and then match the remaining, etc. There are several algorithms. So based on that, it translates. So this is the direct translation, where actually machine tries to build the mappings from the parallel corpus. And this was done earlier in the early stages in the direct approach. What they call it is the word embedding. So it's not just the translation system was developed, but what they try to do is, you have this parallel corpus. From this parallel corpus, they try to model the word of English as well as words of French. So what is this modeling? As I explained earlier, it is just meaning of a word represented as a vector of 1,000 dimensions or whatever. So you have the English word and its representation, a French word and its representation. And you have, in the beginning, of course, machine was told that translation of this sentence is this sentence, etc. Yes? Oh, yeah, there is a typo. These should be models. M is missing. I'm sorry. Yeah. Yeah. So here in the beginning, they had the parallel corpus where it was known that the translation of this sentence is this and so on, from which they could build the dictionary of words, dictionary of phrases, dictionary of various collocations, etc. for these two languages. And then they had the word embeddings. And now what you are doing is you have the words, their representations, and the words from other language and their representation. And from the earlier learning where you know the word mappings, you now are mapping the word embeddings. So essentially, the meaning spaces of two languages are being mapped. And this then they continued further. They said, okay, now we will learn from single language corpus. So from they know now how to model English French or German French or English German, etc. But now suppose a new language comes in. Say now I want to develop something for Sanskrit. How do I do it? I do not have a parallel corpus for English Sanskrit. Then how do I go about it? So what they did was they collected the Sanskrit corpus, and it's available online on several medium, several websites. Wikipedia is one of the sources, and we have Gretel and other sources also, where a lot of Sanskrit text is available in electronic media. Now, after collecting all these texts in Sanskrit, they developed the word embeddings for Sanskrit. So how these word embeddings are developed? They have now technology. For each word, you generate 1,000 parameter index kind of thing. So they developed it for all Sanskrit words that they have gathered from various sources.
They is the Google?
Google team. Yes, Google team. So once that is done, next, what needs to be done? This needs to be mapped to English. But then how to map this? They do not have, there is no parallel corpus which is aligned properly. Well, we have English translations of many major works, but those English translations are not sentence by sentence translations. These might be paraphrases. So in such cases, then what to do? So Google came up with a very, I should say, a very interesting idea and very path-breaking idea, I should say, where only based on the monolingual corpus and the word embeddings or the meaning spaces of different languages, they could map the meaning space of Sanskrit into this. And how they did it? They chose a language, Hindi, which is close to Sanskrit. English and Hindi already they had worked on. So they had the English words and the corresponding word space, Hindi words and the Hindi word space or word meaning representation, and a mapping between English and Hindi also existed. Now, what they did was they chose some small corpus of Sanskrit, some small corpus of Hindi, and manually in the sense the parallel corpus was established, the Sanskrit sentence and its Hindi translation. Some small parallel corpus, maybe, I don't know the size of that corpus. It may be 1,000, 2,000 or 10,000 sentences, whatever. Yeah, they might have taken these. And then from these, they learned the mappings for all the words that come in that corpus. So now they know that the mapping of such and such vector in Hindi is such and such vector for some small corpus. And then Now you have huge monolingual corpus of Sanskrit. You have the mappings for all the words. For Hindi also, you have all the words mappings. So from this small corpus, they extended it to the big corpus, and they established these mappings between Sanskrit and Hindi. English and Hindi already was established, and therefore they could go to Sanskrit and English. I don't know whether they went from Sanskrit Hindi to English or they had separate Sanskrit English, I don't know, but this is something which they did. I should say it is really a path-breaking path-breaking idea which they have done, and they are successful to a large extent, as we have seen. Though there were some problems with 2 sentences, but given that it is just a few days old baby, a few days ago they have released this. In another 1 year or 2 years, you can expect a better system, far better system from Google for Sanskrit to English or Sanskrit to Hindi for that matter. But then what is not possible with this, that also we should know. So many times we say that history repeats itself. Historically, if we look at the developments, earlier there was this grammar-based approach, but then statistics overruled it. And then they discovered that statistics has some limitations. You cannot use statistical approaches always. There are inherent limitations of statistical approaches. And therefore they further decided to go for better machine learning approaches. The just Markov model or Viterbi model, which they were using, was not sufficient. And then it resulted into this deep learning model. Now the limitation, and of course, when statistical methods failed, at that time, again, there was a boost for the grammatical approaches. And there were people working on grammatical approaches further. Deep neural network, the advantage of deep neural network is it can model the context very well in terms of these numbers, vector spaces. But the model that it builds for each word is not human understandable. Machine is learning something, machine is building a model, machine is mapping the word into a vector space, which is the meaning kind of thing. But that meaning is far different from the meaning which we perceive of the words. And that meaning is in the form of some numbers. And we just can't make anything out of it. So if you say that word X has these numbers, where Y has representation as these numbers, and whether these representations are correct or wrong, we can't say anything just by looking at those numbers. No, even mathematician will not know what is it. It's all abstract thing. What those numbers represent, we don't know. So the whatever machine is learning is human ununderstandable. So next thing, in my opinion, is people will go for human understandable machine learning. If we go for human understandable machine learning, then everything will be, but then how to go for human understandable machine learning, that is the issue. But I think if the history repeats itself, there will be a stage where again there will be some fallback to the grammatical systems, and then from that people will understand how to represent the meanings meaningfully, and then the things will work. This is what I have imagined. That's it. So I think I will take up questions now. I will stop here. Okay. So thank you very much. Merci. Dhanyavad.
So maybe I will see whether any chat, anything is there in the chat.
Yeah.
Maybe not. Oh, there is someone waiting to be admitted in the room.
It's
so
almost
welcome,
over. So those who are
the next one is anyway on 2nd June in the morning. Then maybe let me say that very clear. Yes, but there's nothing in the chat. The participants I can see, and I have the addresses, and I sent to most of them. I've sent the links for both. The next one will be on another link, which is. I should maybe. I will not unmute myself.
Okay.
But anyway, so thank you so much for
so any questions?
Very interesting lecture and update also for many issues. They are very old. I mean, this machine translatability. I still remember the time that they said, no, statistics, it will never work. And now we see that that's just what works for the Google translation. So we will have but not reliable, but still, if you have very short sentences of 2 words or something,
even for good sentences, even for Bhagavad Gita, I saw that it's working most of the time.
Something comes out, but with a lot of it's an ocean of salt. Means not a grain of salt, but ocean of salt you have to add. But still, if you it depends. But I think it can be useful for quickly what you say, quickly to get an idea. Is this a text about yoga or about agriculture, an old text about agriculture or medicine, or so you get something out of it. And I think if you have very simple sentences without participles and all that, then probably means it will maybe be little semi-reliable or 60% reliable. And then otherwise you have to become a Sanskritist so that you can understand yourself directly what is the text saying. So I had a question about that triangle and those interlingua. But Gerard has a question, and maybe you please ask questions also. But I want to just ask something about that. So apparently the choice of taking Hindi as the closest one to Sanskrit, it is based on practical availability of a lot of Hindi translation, because Oriya is closer to Sanskrit.
It is because Sanskrit, Hindi, English, Hindi has a good
corpus or something. But is that all? This process is always between only 2 languages, or
no? The direct translation is between 2 languages. But interlingua is from any language to any language, and this interlingua, actually, if we take all Indian languages, interlingua will be Sanskrit.
That is the theory, but it is in practice. It was Hindi now.
No. Well, in practice, yes. Now they are taking Hindi as the central one. Yes, because Hindi corpus is more. But it is not interlingua. See, interlingua is one.
From Telugu to Marathi, how do they do it? Via Hindi or not via Sanskrit? Definitely not.
No, they are not doing via Sanskrit. But interlingua is something which is independent of all languages. So there was an effort by United Nations, and they came up with one UNL, United Nations. I'm forgetting what does L stand for. So universal neural. No, it's not universal. Universal, but what is N? Universal natural language. No, I don't remember. Maybe I can search on Google for UNL. I'm forgetting. No. It's
networking language.
Universal networking language. Yeah. Yes, universal networking language, right. It's universal networking language. So this need not be, this can be a hypothetical language. This can be a hypothetical representation. For Indian languages, Sanskrit becomes a natural interlingua. But it need not be natural interlingua for all languages in the world. So they came up with this idea of universal networking language, where you have the concepts, and these concepts are mapped to various words. So for example, if you are representing the concept of ice, you have ice, snow, 2 words. In Hindi, we have only one barf, which will map to both ice and snow. But if we go to Eskimos, they will have 10 types of these ice, snow, and snow 1, snow 2, snow 3, snow 10, whatever. And then, so that is the conceptual level. So the way the world is divided into various concepts is different for different communities. So they say that India is one linguistic unit, one linguistic, one linguistic area, because there is a lot of give and take among the language families. We have Aryan and Dravidian, the Dravidian and Indo-Aryan languages, Munda languages are there, Tibeto-Burman languages are there, but all of them, they have a kind of common conceptual space because of a lot of give and take. But if we come to English and Hindi, though they belong to the same language family, the way they divide the word into different concepts is different. So in universal networking language, what they try to do is they try to come up with a dictionary of all the concepts from all different words, all different languages. Of course, this was hypothetical. They started, of course, practically with one language. They had the concepts. Then another language, if it needs a subdivision, they added concepts and so on. This way, they went on developing this concept, dictionary of concepts. But of course, the UNL approach now, as far as I know, is not in, there are some efforts going on, but not many efforts. It was the interlingua which they were aiming at. Interlingua, the way Google is doing it is not interlingua yet, but the word embeddings that they are finding, these word embeddings in some point in time will lead to the interlingua kind of thing. But then what it represents, what is the meaning it represents, if it is not human understandable, it is of no use.
But it leads to the correct translation. It means although it is human and ununderstandable, using that,
yeah, it leads to correct
one word in English with one sentence in English.
Yeah, it is the artificial intelligence. There are 2 groups. One is the strong AI and the other one is weak AI. So just to give an analogy, we always the flying of birds have attracted us, but it is the aeroplanes do not fly the same way the birds fly. Okay. Similarly, here the translation systems do not work the same way we translate. Okay.
Nor do they work like binary words.
Yes. So this is the weak AI. What Google is doing is the weak AI. But if we try to follow our intuitions and the way we, of course, is it the whatever grammar Panini wrote, is it the way human being analyzes? Definitely not. This is again artificial, but Panini has given some kind of scientific base to it. So we are trying to look at how the language works and how the information is coded, etc. Whereas the weak AI is not looking at that, is doing it in a different kind of way. its aim is to get the translation. Its aim is not to understand. Whereas our aim here is, as far as Sanskrit is concerned, whatever I said may not apply to other languages. But for Sanskrit, what we are interested in is understanding the text, because translations anyway are available in other languages. We don't need the translations for important texts as such. Already translations are available. But what we are more interested in is understanding the original text per se. And this is what we are aiming at. This is where the goals differ. Yes.
I would like to add something about this Vauquois triangle.
Okay.
What is this Vauquois, by the way?
Vauquois was a French scientist who was working in Grenoble and in the 60s. And this was the first major effort at automated translation. And so there was a big team, and they were partly successful. Later on, this was killed by the negative comments of people who said, you know, automated translation will never work. Like Barry, for instance, who very negative comments. So the effort was killed. But this triangle is kept as an important concept. This interlingua on the top. No? This is not a natural language. It's a kind of aiming at a universal space of notions. So it has to axiomatize all of common knowledge about human behavior, human behavior, and so on. This is sometimes called the pivot language.
Yes. Yeah.
The UNL effort was in this direction, but it was rather naive. It involved a few people, and this died. But there is a much more interesting effort that was done by the real linguist Melchuk in University of Montreal.
Yes.
Word grammar called the sens text theory.
Yes.
This was this idea of pivot language, and he went as far as modeling the meaning of a few French words as a complex graph. So he could not accommodate all of French, but there was a kind of kernel of pivot language that was at least linguistically sound.
Okay. So this is Melchuk's word grammar. It is the word grammar of Melchuk. Yeah. Yes.
Melchuk is the authority in morphology.
Yeah. Yes. Yeah.
Okay,
yes.
So this is for the triangle. I have another remark for Google Translate. That it's very impressive. It's very impressive from at least two points of view. One is very fast.
It's real time. Yeah.
Answer. And the second is that the translation is perfect English.
Yeah.
Okay. But it relies on one assumption. One fundamental assumption is that for any human language sentence, there is one intended meaning. This is what they are aiming at. Okay. Now we all know that in every natural language there are ambiguities. Yes, but still you can argue that that there is a main intended meaning, which is the one you try to capture in translation. But this is not true in Sanskrit. In Sanskrit, you have the phenomenon of shesha, because you have agglutination of words. And then you can play on words and have several meanings. Okay, and this several intended meanings. This is the point. Remember the first challenge you gave me? Gravity. Yes. Okay, so here you have the, if you enter gravity, yes, you in Google Translate you will have the white ones, but you will have no dog.
There is a sentence in Sanskrit which is Shveto Dhavati, but it can have two different analyses. Both are correct. Like it can mean either the dog runs from here or the white one runs.
It's not a problem with you, though. That's the fact that the sentence is untranslatable. So any translation is going to fail.
But there are two analyses, and both can be intended as a joke or whatever.
Sure. No, but is that is
so then it becomes untranslatable.
The two meanings are intended.
White runs. Okay.
But
you can give feedback. You can send feedback and say, I don't agree. Like,
yes, that can be done, and then yes, yeah.
This point, this is the interest to learning the language and of studying the text in the original language. Otherwise,
yeah, sure. But you defeat the purpose of translation. but this example is kind of artificial, yes, because you have either another. But in Sanskrit, it is actually used, yes. Other authors made panegyrics of kings, which can be read as, this king is great, or this king is really a bad hero. Okay, so here you have the kind of literal meaning and the sous-entendu, suggested meaning, and both are needed in order to understand the text.
Yeah, with only one you don't understand anything.
Yeah.
But even in daily life, you have many jokes where it is intended.
Yes, yes, and these are the limitations of these are the limitations of translation, I would say, not machine translation. These are the limitations of translation. So all the limitations of translation will be applicable to machine translation as well. This is where we need accessor, not the translation system.
And for this kind of work, the human translations are kind of bizarre. Often they say, they give a straight meaning and then, oh, I mean to say, and then they give it to the behavior. Like you say with that, they do the original.
You said that in some Adani
yes, correct.
Project, it's possible to have the output on every stage of the processing. And what kind of output can we have?
Okay, so I thought I will show it day after tomorrow. Maybe I will show it now. So here we have this shloka, eko raso karuna eva, etc. Now,
by the way, officially,
so shall I continue on? But just in 2 minutes, I will explain something.
You want to talk more about it also in the...
Yeah, in the next, I will be talking more on this.
So
but in 5 minutes, I will just say what it is.
So throws us out, then we can stay. But
fine.
I don't know whether the Zoom link will suddenly go or whatever.
Oh, okay.
I have reserved for 2 hours.
Okay. So here we have this shloka, and machine has done the given the prose order of it. Actually, there is something wrong in the prose order. Then you see here there are 4 rows under each word. So below karunaha, there is karuna, and then pu, this is the masculine, this is the case, and this is the number, eka. So it has given the morphological analysis of this word. In fact, it's possible that a word has more than one analysis. The one which is chosen by machine in the given context is shown here, but you can see other analysis as well. Yeah, here it is. This was a sentence where, here if you see, Vedat, this bheda can be either a masculine or neuter. So both the analysis are shown here. Okay. Similarly, no, here this is a sentence where only one word is ambiguous at morphological level. So machine shows both the analysis. And then one can choose, depending on the context, whether it is masculine or neuter. Machine had chosen neuter for some reason, but it might be wrong and it should be masculine. And if you feel so, you can go back and select the correct one. Now here I have shown you only the morphology, but we can also see the sentential analysis. Machine says that there are 8 possible analyses. Only first analysis is shown here. But then you can go and choose the one which is correct in the given context if the first one is wrong. So at the level of morphology, at the level of sentential analysis, also at the level of segmentation, which I will be showing in the next demonstration, next talk, you can make the choices. So essentially, when you analyze any language, you need to analyze it at phonetic level, at word level, at sentence level, and machine, we have these modules ready where machine shows all possible analysis. One can go back and select the correct one if the chosen analysis is wrong one. Okay.
And is it possible to download to export morphological analysis for whole text, for example?
Right now, it is not possible. You cannot just upload the whole text and get the morphological analysis. But there are 2 ways to do it. One is to download our system and install it on your machine and then run it. Another possibility is you send the text to us and then we run it and give it to you.
How much does it cost to download from your site?
It's free.
Wow.
You can download it and install it on your machine. But of course, we are... On PC or you need Linux machine. Linux. Yeah, you need Linux machine. And of course, there is one ongoing project where we are... tomorrow, I will be explaining more about it. Day after tomorrow, I will be explaining more about it. We are trying to build the readers using this analysis. So we do the analysis, save it, and then compile all these analyses together to make a reader for a particular text. So one project is ongoing where we are trying to make it automatic. So and provide, not automatic, but provide a kind of desktop to the researchers where researchers can upload a text. Machine will do the analysis and present it to them, and then user can go and improve upon it. The researchers can improve upon it. So that that project is ongoing. So maybe in another year or so, this whatever facility you need will be available to you. So you will be allotted, you will be given a workspace where you can upload your text and machine will automatically analyze completely and then produce it to you, and then you can go on improving upon it further. Okay.
Other technical things which you have, let's say, invented in the course of time with regard to Sanskrit, which you could apply to Latin, for instance, because it is also big corpus.
Yeah.
Has there been any exchange with
not yet. Actually, there was some exchange with people from working on Latin, and it was in 2019 when I came here for the Syntax Fest conference, which happened in Paris. And that time we had some exchanges, and they wanted me to attend some conference where we would be discussing more on it. But because of COVID, it never happened, and not yet. But maybe sometimes it's possible because Latin also has similar kind of syntax as of Sanskrit. And they have some 5 cases. And so it's possible that the kind of sentential analysis that we do is extendable to Latin as well. But as of now, we do not have any further conversation on it.
So maybe it's 4 o'clock. Maybe we should officially conclude for today. I mean, even we can continue informally. But yes, so you have. So thank you very much, everyone. And this was a little, how to say, improvised session. We hope that, well, next time everything should function in a better way. And any remaining questions, it is for a longer discussion, is to be kept for next time. I don't see anything in the chat for now. So thank you for your presence. And then the next one is on 2nd June.
Yeah.
2nd June, and it is in the morning from 10 to 12.
It's 10 or 10:30? It's 10.
10 to 12.
Okay, 10 to 12. Okay, fine. Yeah.
And then it is subsequently, it is the next 3 Thursdays, it will be continuing. So thank you very much
Thank you.
so far. And,
thank you very much. Thank you.